Hey, this is Jody with weldingtipsandtricks.com. Thanks for watching another weekly video. Well, I've had a chance to play around with this Ironman 230 for a while now, and I've done quite a few jobs with it. So this is a summary of quite a few of the jobs that I've done with it. We did welding 1-inch plates to the side of these sewer crawlers, and did some welding down in a flare bevel V weld like this. Around the roll of a square tubing with a long stick out around the radius cutouts of those side plates, those 1-inch side plates. Also had a chance to weld with some straight CO2 on 1/4-inch hot rolled and compare it to 75-25 argon CO2. Did some slicing and dicing to check for penetration on the straight CO2 versus the 75-25. A little polishing, a little etching, check for penetration, and saw that that machine penetrated very well with the right settings. So with the voltage tap settings, it does not have an infinitely adjustable voltage setting. It's got click taps. Was it adjustable enough to lay in a root pass in an open butt V-groove weld like this, where you kind of have to set it pretty close to be able to make things happen? So wanted to find out, so set one up and did it. On an open butt V-groove like this, you got to keep that wire like right at the front of the puddle. You stay back too far in the puddle, you won't penetrate. If you stay ahead too far or the machine's not consistent, you shoot wire through. So you got to be fairly close. You can make some adjustments with stick out and with travel speed and all that, but you got to be able to adjust the machine pretty good to lay in a decent root pass. And it did fine on that. Now here's some 1/8-inch wall hot rolled square tubing like you would just fabricate stuff out of all the time. No surprises there. Laid one in there pretty good, almost spatter free on that. Didn't even really fine tune it that much. And some 1/8-inch cold rolled steel, just saw cut stuff here. Almost the same settings as the 1/8-inch square tubing. No surprises there. Well, some flat, little downhill. And then some 16 gauge. That's about as thin as I had laying around, but it's hot rolled, it's plasma cut, not very clean. Still had to set the machine down kind of low. But I'll tell you, on sheet metal like this, the biggest thing you can do if you're able to is position it where you can weld downhill, and that helps it go better. And here's a tip for us old timers that eyesight's not that great anymore. If you turn the machine a little colder, go a little slower, and then play the arc around in little circles like this, it plays the light around from left to right, and it helps you really see where you're going a lot. I find it helps me anyway, because I'm kind of over the hump as far as eyesight goes. Well, let's take a look at some of the other stuff on the Hobart here. The plastic hose reels you can hang your spool gun and stuff on. The settings chart on the inside. It's even got part numbers for tips and things. A switch for the spool gun to go back and forth from steel to aluminum, a place to put your contact tips and consumables. That's pretty handy, and it's pretty dang substantial cast aluminum wire feeder mechanism here. Pretty decent. All right, let's swap over to the spool gun. But first, let's talk about polarity here. This is where you change the polarity. You need to be on electrode positive for doing bare wire MIG, and also with the spool gun aluminum, but not everything runs electrode positive. If you're running some flux core wires, you need to swap it, and you need to check the manufacturer's recommendations, because a lot of people have pulled their hair out by not doing that. It comes with a really above average ground clamp with the dimpled copper alloy jaw on it there. And so now we're going to swap over to the spool gun. I'm going to get the steel wire snipped and out of the way, pull the regular steel MIG gun assembly out, and put the spool gun in. Now here's what that looks like. The spool gun hooks up like this with just a solid block where the wire feed doesn't feed through there, because it goes uses the spool gun for the wire feed. That's what it looks like. That's where it makes its electrical connection, on that block right there. And here is where it gets the argon feed. There's a little small port right in here. There it is. About a 1/16 port. That's where the argon or shielding gas, whatever you're using, feeds through. So you need to have that thing fully engaged, and the double O-ring deal kind of seals that off and lets it feed shielding gas like it's supposed to. But you need to push it up in there all the way, and then get this little nut here good and tight so you get a good electrical connection and it doesn't wiggle loose. All right, before I welded thick aluminum, I got a thick aluminum fixture to do. I wanted to set the machine settings and verify that everything was going to be cool. Not too much spatter, not too much soot, but adequate penetration. So I did quite a few little welds on 3/4 inch aluminum plate. Did some vertical uphill in case I had to, and then also some double pass, little weave second pass vertical uphill. And then sliced and diced that too to check for penetration. Got a little polish, good a polish as I could on it, and then a little etch. And I just used the household product to etch here. A lot of household products are really high alkaline, and actually I used Drano here with a swab, cotton swab to etch, and then kind of check my penetration. So I had a void in one of them, and it was the one that I welded first with no preheat, because the rest of them had preheat just from welding, heat build up in it. So I could tell I was gonna kind of need to throw a torch on this thing and get it warmed up in order for it to weld like I wanted it to. Because you can see that center hub is pretty thick. That's almost 2-inch thick aluminum in the hub, and then the rest of it is pretty much 3/4 inch 6061 T6 aluminum plate. So it's quite a heat sink, in other words. So no matter how much power you have with a spool gun, it's going to try to draw the power out and not. It's going to kind of resist flowing. So the hotter you can, to an extent anyway, if you can get some preheat in there, it just makes everything go a lot better. You have to use a lot less energy from the gun if the metal's already hot. So again, a closer look at this thing. That's 2-inch thick hub, and I'm going to throw some heat on it with this rosebud. About 200 Fahrenheit preheat is a good preheat for something like this. That's low enough that you won't lose too much temper of the heat treat of the weld. So I verified that with this infrared heat gun. And now I'm ready to fire up on it. And sure enough, the preheat did make quite a bit of difference. Because the first one I welded, this is number 2 of 2 fixtures. The first one didn't quite go this well. This one's going pretty nice. And that's what it looks like. All right, so the Ironman 230 is a pretty darn good value. Right now, if you check at places like Northern Tool, you can find a really good deal on it with the spool gun. Very capable machine, very affordable. So that's my spiel for today. Thanks for watching, and visit weldingtipsandtricks.com.